Hi, good afternoon, everyone. Here I am going to explain the topic of pumps, and the subtopic is centrifugal pumps. Generally, the pumps are classified into two types. Number one is positive displacement pipe pumps and the rotodynamic pumps. The example of positive displacement pump is reciprocating pump. Again, it will be classified into two types. Number one is single acting pump, and number two is double acting pump. All the reciprocating pumps are works on the principle of pistoning action. The liquid is sucked, that is, the liquid is sucked into the cylinder from the sump. Again, it will be pushed the liquid into the delivery pipe by the using of piston. So when we came to the rotodynamic pumps, the example of the rotodynamic pump is centrifugal pump. It will be works on the principle of centrifugal action. In this class, we are able to learn the main component parts of a centrifugal pumps and their functions, and the use of foot valve and the strainer. What do you mean by centrifugal pump? Generally, what do you mean by pump? Pump means it is a hydraulic machine which converts the mechanical energy into the pressure energy by means of centrifugal force. Later, it will be converted to the hydraulic energy. The main function of the pumps is it can be lift the water from lower level to the higher level. Here we can see the main parts of a centrifugal pump are seen in the figure. Here bottom of the figure we can see that the foot valve and strainer, suction pipe, eye of a impeller, casing, delivery pipe and delivery valve. In the exam he can ask the figure also. You can draw the figure and give the component parts of a centrifugal pump. You can ask like that. When we cut the centrifugal pump, inside of the pump you can see like this: impeller, volute, section, impeller eye and discharge. What you have seen in the figure, the component parts are impeller, casing, suction pipe with foot valve and strainer, delivery pipe with the delivery valve. These are the component parts of a centrifugal pump. Initially, let us discuss about the impeller. It is a rotating wheel which is fitted a series of backward curved blades or vanes. The impeller is mounted on a shaft which is usually coupled to an electric motor. Just now we have seen in the figure about impeller. It is in a rotating wheel which is fitted, which is having the series of blades or vanes. It should be mounted on a shaft. Next we can go for the casing. It is in a airtight chamber. It is an airtight chamber and covering the impeller. The casing should be designed such that the kinetic energy of the liquid at the outlet of the impeller should be converted into the pressure energy before the leaving the casing. While you are designing any casing, the casing should be designed like this only. Next we can go for the suction pipe with foot valve and strainer. Suction pipe is a pipe which connects the sump with the pump inlet. The upper end of the pipe is connected to the center of the impeller known as the eye of the pump, At the lower end of the pipe is dipped into the liquid in a sump. The lower end of the suction pipe is fitted with a foot valve and strainer. If you observe the figure, we can imagine, we can understand easily. The lower end of the suction pipe is fitted with the foot valve and the strainer. The liquid first enters the strainer, and the strainer is provided to prevent the debris entering into the sump. This is the function of the strainer in a pump, is provided to prevent the debris entering into the pump. The liquid then passes through the foot valve to the enter the suction pipe. The foot valve is a non-return or one-way type valve which opens in only in the upward direction. The foot valve does not permit the liquid to move back to the sump when the pump is not working. This is the main function of the foot valve. This arrangement simplifies the operation of starting the pump because the wheel by its rotation cannot create vacuum, otherwise needs the priming of the pump by filling it manually with the liquid. If you use the foot valve and strainers, the priming is not required in a pumps. Go for the delivery pipe. It is a pipe whose one end is connected to the outlet of the casing and the other end delivers the liquid to the required height. A delivery valve is provided on the delivery pipe to regulate the supply of the liquids. So in this we will have different types of casings we have to adapt, we have to use for the pumps. Those are volute casing, number 2 is vortex casing, and the number 3 is casing with guide blades. Here we will discuss regarding the volute casing. It is a spiral, please see the figure here. It is a spiral shape casing which surrounded the impeller. The area of the volute casing gradually increased from the impeller outlet to the delivery pipe. Here you can observe that the area of the volute casing gradually increased from the impeller outlet to the delivery pipe. Due to this, the kinetic energy converted into the pressure energy before the liquid is leaving to the casing. When we use the volute casing, the pump is having the less efficiency due to the more eddies are developed in this type of casing. Means the loss of energy is more when we use the volute casing in a pump. In volute type of casing, there is only a slight increase in the efficiency of the pump because a considerable loss of energy takes place in the eddies developed in the casing, because the way gradually increasing area is more. Due to this, the eddies are developed in the casing is more. Next you can go for vortex casing. A circular chamber is provided between the impeller and the volute chamber. The casing is known as a vortex casing. You can observe the figure. A circular chamber is provided in cities with dotted lines between the impeller and the volute chamber. The casing is known as a vortex casing. The circular chamber is known as a vortex or whirlpool chamber. By providing the circular chamber, the loss of energy due to the formation of eddies is reduced due to a considerable extent. Hence, the efficiency is more when we use the volute or vortex casing in a pump. The efficiency is more in this pump when it compare with when we use the vortex casing in the pump. Next, we can go for the casing with guide blades. You see here figure. In this type of casing, the impeller is surrounded by a series of guide blades or vanes mounted on a ring which is known as a diffuser. The liquid leaving the impeller enters the liquid vanes without stuck and passes through the passage between the guide blades. The passage has gradually increasing the area, thus reducing the velocity of flow through the guide vanes and consequently increasing the pressure of the liquid. Means in this the efficiency is more when it compared with the vortex casing and volute casing in this type of casings. Thank you everyone.